Hello, hello everyone. Okay, fix this again. Now we are live. Ooh. Yeah, it is 10:35 p.m. time in Moscow, in St. Petersburg, and in Gomel, and in a lot of other places. And today we are doing Snark News Winter Series round 5, which is the last one in the series. It consists of 5 rounds, and the rounds are all independent. Each of the rounds has 6 problems, and there is no like progression like you may be used to in competitions like Google Code Jam. You do round 1, you advance to round 2, you do round 2, you advance to round 3. It's not like that here. Every round is just a standalone round, and then the rounds are just added up using some Grand Prix system, which is 100 points for the first place, 75 points for the second place, 60 for the third, 50, 45, 40, and so on. And so that's how the current results look. And we are quite ahead, so we don't, to win the series, we don't need to do much. It's not really important, it's more like training, but just to show you what the things are. That's what happens, and then there are multiple people very close for the second place, and we need to get at least 14 points, which is at least like, yeah, like 16th place, 17th place is good for us. So yeah, that's one, maybe even one thing answering why I don't use blind submissions. Yeah, just because blind submissions add too much randomness, and like I don't like, even if you take second place in every round, you just probably win the series. So just there is no need to like risk for me. Yeah, so going to the round window once again ends in 23 minutes, and we start pretty soon. Yeah, as always, we'll have 6 problems. Let's create some folders. Yeah, I don't know which problem I will solve first, because the problems will not be sorted by difficulty. Yeah, and I will translate them using Google Translate as usual. Does my shirt mean tiny C compiler? Okay. No, it's actually TCO, even though you only see it like TCC, but it's actually TCO 14. So yeah, you may see the second part of the text on my back, which is kind of fun design. Yep. And also starting from today on Twitch, you've been using TCC too much lately. Yeah, that's fine. Starting from today, you can accumulate channel points if you really want to. I mean, they will be accumulated even if you just watch, so that's fine. And if you really want to, you can also subscribe. I'm not sure what will happen, but we'll know. So we are starting in a couple of minutes, maybe at 42. I don't know. And yeah, as always, I will try to be competitive, so I will not explain the problems on the go. I will discuss them after the fact, after I do all of them. So I will just mumble something, but I won't be trying to really explain my solutions. So yeah, let's start at 42, I think, in 2 minutes. And yeah, I'll try to not forget to start the timer on the screen as well. Hmm. Yeah, I don't know, it was some lag. I'm not really sure what happened. Anyway, I hope that doesn't happen during the contest. Yeah. What? Is it okay? Yeah, I hope I'm back. Oof. I see some dropped frames though, which I don't really understand. Hmm. But it, yeah, there used to be no 720 is too low quality. I tried 720 and yeah, no, the contest is not over. I was going to start 2 minutes ago, but I will start shortly. If it's fine, yeah, tell me if the quality is fine. Like, I don't know. Yeah, I guess it is. Stream crash. Hopefully no. My voice is echoing. Is it? Is my voice echoing? Okay. Yeah. Okay. Yeah, sorry about the lag. I don't know what happened. Let's check if Code Forces still has my stream. Well, it has for now. My thought about the last Division 1, what could I have done better? I could have solved F, obviously, but I didn't manage to solve it. And that was basically it. That was just summarizing my performance. Like, I did fine on the first 5 problems, and then I just got stuck. Like, I don't know. Hard to really explain, but that's just what happened. Okay. Starting in 30 seconds then. Okay. So once again, yeah, I won't be actually reading chat, but please feel free to discuss anything. Let's go. Okay, and stand-ins. Okay. Interesting. Okay, so I have some picture. I want to find the shortest path between some points. Well, looks a bit fun. Hmm. Okay, difference. So I guess just solve for each and just subtract. How to solve for each? What? Okay, just okay. What do I want to find? The difference between okay. I guess this way. So yeah, one guy is just shortest path and the other is tricky shortest path. Really? I don't know. Let's just copy some stuff. Is it actually directed graph? Yeah, it is kind of a directed graph. I guess just use Dijkstra, right? Just whatever. What? What is this? Okay. And the other graph should have something like n times 13. I hope it's not too slow. Yeah. Yeah, I can also just wait. Okay. So also difference. So it's like, is it absolute difference or just difference? really no idea. Okay, solved C, tried A. Okay. I guess I started with the wrong problem, but it's okay. Okay, let's just see what happens on the examples and then what? What is this? 1350? Oh, wait. Okay, sure. What is this though? 13 and 50? Okay, 0, 3, 1, 3, 2, 2, 1. Okay, yes. I needed to add some, yeah, undirected edges. So yeah, I also need this. That's true. Okay, 13 and 32. Yeah, it looks right, probably. How many knights do I need? GG over 12. I think -1. Yeah. Okay. Unknown. Yeah, so it doesn't matter which difference is asked for. Okay, let's submit. Okay, A and C solved. Interactive. Okay, what about A? Okay, F accepted, good. Okay. -1, okay. Yeah, so what, you have some hash and you want to find strings? Like what? Not smaller than S of length and K of them, so that They all have the same hash, but what do you mean? Just try random strings? Maybe. Because we only have 10. Wait. What's this? Okay, I see. I see what's going on. So what? How did it happen? Like, why does translator just change SNWS into SNUS? Like, why would you think it was a word? I really don't understand, but okay. So yeah, we just increment and recalculate the hash. So okay, I guess something like this is the best we can do. And now okay. Yeah. And now what? From 0 to 26? Are you sure? What do I mean by from 0 to 26? Well, it doesn't matter, right? But like, yeah, okay. I don't know, I don't like strings. Let's have vector int. Okay. Okay. And now we just have to increase our screen. Also have to print the strings. Have just, I guess, just save the IDs. Save the initial S and yeah, IDs B, IDs F, save ID. Now I want to make a new string, so I go from -1 to 0. If it's 25, then do this. Otherwise, do this. Then do this. Yeah, also. One string just print it. If you have more strings, yeah. Whatever. And now, okay, just copy because like who cares? Initialize this way. ID 0. Okay. Oops. Yeah, okay, I don't need hash. And do this, I think. And now what is check? Why am I doing it this way? Whatever, I guess. Okay, I think this will work. Oof. What? Vector of +1, right? Yeah. Okay, let's submit. Okay, so C is the next problem. Okay. Yay, A accepted. Good. We have 2 problems now. And we are in the first place. Hype. Yeah. Um. Two players play, a guesser and a guesser. Yeah, I guessed. This is ridiculous. Okay. Okay. So, um, yeah. So the trick is that yeah. What is the trick actually? I just need to assign some distinct number to new cards, right? Right. Yeah, should be easier, but I guess whatever. Yeah. Yeah. Wait. Does it even work? No, it doesn't, because yeah, it doesn't. What? Two out of 12. Okay. Yeah, okay, this should be the next problem to solve, but like what? Why am I stuck? Um, Wait, so I need at least 2n-1 moves. So let's say I spent n over 2 moves, and then I only spent n moves. Yeah. I need to ensure the aggressor spends at least 2n-1 moves. So I get 1 and 2, and then what? Like when I get a new card, if it's 1, just like, yeah, my opponent just matched it into 1. If it's 2, I just match it into 2. But what? Hmm. Get a new number. If it's equal to some old number, just print, right? Oh wow, so you have to give some, yeah, what? Like if it's the first guess, I give a new number. And if it's a second guess, I give some used number. Like any used number, right? So I actually don't need any vectors, I guess. I think I just need like 2 variables. Okay. No, this also doesn't work. Why? Yeah, like this. Yeah, I don't want to check what happens with priorities. IY here. Is it it? What? No. Yeah. What? Yeah, so the first two cards, yeah. First and this. Wait. That's the first step. And n is greater than 1, then I actually have to take v1. But otherwise, it's like this, I think. No. Come on. Oh, yeah, it's okay. It's actually okay, right? Is it? Yeah, it's okay. What's this problem like? Okay, let's submit and then see. But I don't really understand. Wow, okay. Okay, E solved in 24 minutes, okay. Okay, C is running. How to do E? Maybe just some. Can it be a flash? Not really. Not really. Like, probably too slow, right? Okay, C is probably working. Wait, what? Okay, that's not a blind submission. But yeah, it's funny. So, okay, let's read the other problem section. Okay, C accepted. It was really tough. Interesting. Mm -hmm. What's this example test case? Oof. It was kind of interesting, but yeah, I don't see it yet. What's D? From 1 to 18, okay. Interesting. $100. Okay, so we have 4 to 36. Is it just DP 4 to 12? It's probably too much, but maybe I can. Like, yeah, there's probably some DP on broken profile, but like, what is this shape really? Okay, more people solve E. Timon Sobolev. Wow. What a time to be alive. It can be 0, 1, 2, 3 chips on 3 cells. Okay, so on each cell I can put some number. On each empty cell I can put some number of chips. Yes. Okay, so yeah, so one thing influences like this one, these things. Yes. I don't understand yet. Okay. What is E? Shortest pass on these things. Okay, 300, so I can do some BFS, like not even BFS, but like Dijkstra, but like it's n cube. kind of. Not really, I don't know. So like, yeah, if I want to see what I can see from some point, like I can see all of this, and basically nothing else, right? Yeah, it's just nothing else. Okay, I think I have some idea. Okay, let's try it. So yes. What is one? Let's say, is one even good? Okay, let's just, I don't know, let's use the constraints, because whatever. So, okay. Okay, so okay. Yeah, so if x is even, well, actually, yeah, if x is odd, actually, okay, let's do something. Yeah, okay. This way, I think. And here. Yeah. Like this. Okay. What? Okay. Don't be stupid, right? Also this and this. Okay, 2. Okay, let's submit. Okay, 3 submissions to B, 0 submissions to D. Yeah, D is very likely just some DP on broken profile, but like I don't see what the size of the state is. Okay, E accepted, good. Okay, B and G left. Yeah, I should probably try to understand the state. Okay, let's say I have some, some grid. Okay, I have some cell. And it's the last cell for this one. So I need to know this one kind of. So I kind of want to know these cells, right? Which is 4 to 12, which is 2 to 24, which is too much, but is it really too much? Like, for example, in this case, I have a cell which contains some chips, right? Which contains like something. Like, a cell sometimes doesn't influence anything. It's really weird. Oops. Yeah, so like for a cell with a number, I don't need to have anything. So I think if I just prune like this, it's good enough. How can I do it, really? 35 minutes. Okay. Like I only need to know this number because of this cell. And the same. Like all of these things only influence these points, right? So I actually only need to know these numbers for just one reason. Not exactly, right? I also need this one. In this case. How do I transform this into code? I think it could be just, yeah, like, let me save the numbers in these cells. And then just keep rolling, like, let's try the most straightforward thing, and then when it gets time limit exceeded, we'll figure something out. Hmm. Mm-hmm. So yeah, once again, for each cell, just the remaining number, right? Right. And I need at most 7 such cells. Like C+1 cells, right? Yes. Then I have a cell like this. It influences this one, influences this one, influences this one, influences this one. And also actually this one and this one, yeah. No, I don't understand. Okay, what is even more straightforward? Let's just have, let's have what? Hmm? Whatever. Don't think it matters. Mm. Mm. Okay. 0, -1, 1, -1, 0, 1. Okay. Okay. Now what? Yeah, this is what I will have to use, but okay. Yes. This is what I need to do here. Limit ni and j, subtract 3 if the cell is not 0. Yes. Now here I take some state, I put some value into my cell, so it means that yeah, once again, like it's the same here. If yes, okay, just this. Okay, I think something like this might work. $100, yeah, thank you. Okay, let's submit, because like, why not? 25 minutes. D blind, B blind. Okay. Yeah, with this solution I would never submit D blind, but with some other solution I could. What is B? I have some tree. Okay, D accepted in 3 milliseconds. Yes, thank you. What is this? Okay, whatever. The expected value of the maximum experience. So yeah, D solved. B remaining. Okay, I have a tree. I have some queries like with some probability, add one actually, right? To some subtree. And the question is, yeah, the expected value of the maximum. So also other constraints, right? 10 to 5 vertices, 3,000 queries, and 10 to 4 initial values. Okay. What is probability that the result does not exceed some value. Even this is kind of hard to evaluate, isn't it? Like, also, what is the 2 seconds? These constraints are pretty weird for 2 seconds. Should I look at some... What? Wait. No, like... Okay, only 3000 queries means that I only actually need... Like, I only actually care about 3000 vertices in the tree, right? That's what matters. Kind of, right? Yes. So I can compress the tree. Does it help? I can then just do some DP. Like, I have some subtree, and DP is the expected value of the maximum if I only consider queries inside this subtree. Right? Right. And then I just need to merge children, which is simple. Yes, I think something like this should work. Like in general, yeah, like it works in general for like n times max value, right? Does it just work? I just have some DP of sub3 and value. Yes, I need to max equal, then I need to shift like with some probabilities, like, right? Right. Yeah, I think so. So the only question is how to not make it slow, not make it work in 10 to 5 times 10 to 4. How to do that? 9, okay, 20 minutes should be enough if my idea is right. So I have some vertex. Like in many cases, I just don't need to do anything. Like, yeah, stuff only happens in like query vertices, kind of. How to implement it easily? How to implement it easily? Okay, I think that'll work here. Okay. I think the way to do it is like this. So yeah, let's copy the input. Yeah, this. Okay. 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 Mm. Should be an easier way. So have some subtrees, have somewhat. Okay. Yes. Yes, I think like this. So I go backwards, like I go from the end and do stuff. And what does stuff mean? I think this, I like this better. So and here I actually need to do some merging, but I only need to do that a small number of times. Okay, like this always happens, just pass. This happens sometimes. And then this happens. And it basically means what? Hmm. So weird. I don't really like subtraction. Can I do without it? Okay, do probability that the value is... Okay, let's keep subtraction, then we'll see. So, yeah, like this. So sketchy, I don't know. Yeah, also I need something else. I'll do it now. So, yes, I think like this. Yeah, this code is becoming really messy. Like super bad. Okay, so after this operation, I am normalized. And now I want to add one. How much time? 9 minutes. The example is really not helpful. What is max of PIPJ? What is this? Like, what did I mean to write? X here, probably. Okay, P is not even used, so like whatever. -2 here is what I wanted to type. It doesn't help. Why? Why do I have any... Maybe. Okay, but like... Okay. I want to test it, probably. Or just submit, I don't know. Let's make some small test. Sad. One more 0 here. Okay, what about 1 here? What is 125? What? How can it be 125? What are you talking about? What? Point 0.75 to 0.75 still. What if I make another one? 3.25. Come on, like it's not even funny. You cannot reach 3. What is 3.25? Dude. Okay, the probabilities are just greater than 1 for some reason. Like the total probabilities. Yeah, because here I have to go backwards. Okay, let's just submit and then I don't know. I don't really believe in my solution. This code's really bad. Well, maybe I should believe, but like, okay, passed up to test 10, but like, accepted. Okay, yeah, just believe. Oof. Okay. Yeah. Oh, that was tough in the end, especially. But yeah, good game. Oof. Yeah, I don't know. This code is just garbage, honestly. Just forget it. Yeah, prediction result is all. Okay. 84% of you believe they will solve all problems. Oh, okay. Let's wait for the end and then, yeah. I guess I'm pretty satisfied with my performance today. No wrong submissions, that's good. No, I don't even have a LeetCode account. Sorry about that. This is the last round. This is the 5th round. This is the last round of the series. So yeah, no more SNRK News series rounds for at least half a year. Maybe there is SNWS Summer Series. It's probably in August usually, so I might stream it in August, but before that we are only left with Code Forces at Coder, you know. Maybe other platforms as well. Yeah, the purpose of these rounds is like no purpose, like just training. I mean, it's kind of a competition. Like there is a trophy for the first place, and I think there are medals for the first 4 places, provided by SNWS, who is the organizer of it. But that's it basically. And for me as a streamer, the purpose is that this is a contest, which is pretty rare, that I can stream live while also being like challenged really hard. And like I cannot do Division 1 on stream, like I cannot do Code Forces on stream like live, right? Because people will just copy my solutions, but in this case people won't copy, so I can just do it live. But yeah. Oh, okay. Yeah. Okay, ending in several seconds. Okay. Omnic and Kevin solved the 5th problems in the last minutes, which is... Yeah, Kevin made a blind submission, but it didn't help him because he has so many incorrect attempts. But he solved B in like 14 minutes. I should just... Yeah, I should just learn from him. I don't know, like, yeah, I won't be telling about my plans for now. I think I will keep doing some Code Forces or other contests, but I can't say how regular it will be. Hi Kevin, how to solve B? How to solve B so quickly? Like, yeah, I don't know. My solution to B is just garbage, honestly. No you, yeah. Keep good. Yeah, how to solve C in 5 minutes? That's also actually like I have, even though I won kind of convincingly, I still have a bunch of questions to people around. So yeah, what the problems were about, like problem A. Oh yeah, so problem A was just you have some, yeah, you have some hash, like which is a polynomial hash with coefficient A and modulo B, but B is at most 100,000. And you have a string and you have some number k, and you want to generate k strings which are not smaller than s lexicographically and all have the same hash. So the solution is just you take your string and you increase it by 1, kind of like what you would do with numbers in decimal. That's kind of what you do in like in base 26 here. So you just increase by 1, you recalculate the hashes, and then when you get k strings with the same hash, you just finish. And since you have at most 100,000 different values of the hash and you need 20 strings, you need to do that at most the product of this number, so at most 2 million times. And adding a 1 to a big number 2 million times is fast enough. Like you just do that. You misunderstood A as the same checksum as S. You upsolved it with that constraint and it passed. Wait, but the example, yeah, the example answer is then incorrect, or is it correct? S. Yeah, the example answer is just incorrect in this case. Okay, so Kevin told us how to solve B. He did 3 DP and he returned map of max into probability. And you just merged maps in like, yeah, with like 2 pointers, right? Yeah, also, what about, yeah, so what if you have a tree of size, yeah, a tree of depth 100,000? Yeah, so we are talking about B. Let's open B. You have a tree of depth 100,000 and you have 3,000 queries to the leaf of the tree. So you just have, like, do you just return map from your recursion, or do you return like a pointer to a map? Maybe, but like you still have to merge sometimes, right? Yeah, if you, yeah, obviously. Okay, so if you have just a long pass and you have one vertex from each, I mean, whatever, yeah, it should obviously be too slow. I think it should be too slow, but okay, I guess you're just strong. Yeah, so my approach was basically, yeah, I wanted to do the same, but I realized it's too slow. Also, yeah, size 1 times size 2 merge. You can do it faster, right? You can just do 2 pointers, of course. It wouldn't help on that test case, but yeah, you can do it. And then, yeah, so my idea to kind of compress the tree, but not compress it in fact, was that I maintain a vector of like, yeah, probabilities, like which is kind of a map, like just a vector, because why not? Because we have values from 0 to something. Just because accessing vector is faster. And then I also have some variable bound for sub3, which is like telling me that the value is the maximum of the actual index in the DP array and this bound. And then if I don't have any queries in the sub3, I only have bound. I don't have any DP. But like, I guess it can be implemented like easier anyway. I don't know. Like, but then like, yeah, my idea is that if I have some queries in 2 different subtrees, I need to do a merge, but I only need to do the merge at most like 3,000 times. And then I can afford merging in linear time, which is like 10 to 4. So that's fast enough. And if I have a query, I also like apply the transformation to my DP based on bound, and then I just apply the query, and then it's again 3,000 times 10,000. So I don't compress the tree, but like if something happens only in one subtree, I only just use that DP array and like just swap it into my DP array and only update one value, which is the bound. So that's my idea. Yeah. Okay. So yeah, C, I don't know. Yeah, a guesser and the guesser. I kind of love it. Like in Russian, it's отгадывающий и загадывающий, which only differ in the first 2 letters. But when I translate it into English, it's a guesser and a guesser. Like one person, the guesser and the guessee. Yeah. Yeah. Yeah, in Russian it's отгадывающий and загадывающий, like only the prefix differs. And yeah, the guesser and the guessee is actually what I would love to see here, which would still be not really readable, but yeah, you can guess from you can understand from the context what this problem asks you, but yeah, it's funny that you have two different, yeah, two guys with the same name. But like what the solution is, like like you have to, like it's the game of memory. People open two cards one by one, and if the cards have the same number, they like take them away. And so our enemy plays this memory game, and we are allowed to like use the information and like adapt to the queries of our enemy and make any numbers on our cards. Yeah, there is a nuance. Yeah. So yeah, my solution was just, what was that? Eventually it was pretty easy. Like the idea is that when I have a new pair of cards, well, okay, I have not a new pair of cards. Let's say like I have some pair of cards asked. Like I take for each pair of cards, if both cards are already known, like I cannot do anything. I just return the same numbers. But otherwise, if both cards are unknown, I take the smallest unused number and assign it to the first card. And then for the other way around, like if only one card is unknown, I do the same. Like to the only unknown card in the pair, I assign the smallest unused number. And if I actually take two cards from the pair, I take like the first unused number from the second set. I don't know how to say it. Like the basic idea that is that if I just ask cards one by one, so if my opponent just asks cards in order, like card number 1, 2, 3, 4, 5, and so on, I will return 1, 2, and then I will return 3, 1, 4, 2, 5, 3, 6, 4, and so on. Like my only goal is not to allow my opponent to use the information which I give after the first unknown card. Like the worst that can happen is that for the first card in the pair, I give some number which is already written on some different card. And then my opponent just takes that different card and just takes them away. That's the problem. Like that's the worst thing that can happen. And I just try to avoid it by just assigning the first unused number to the first card in the pair. You maintain the set of cards for which only one instance is opened at the moment, and this set was always at most 2 cards. So like it's kind of the same, like it's still the same idea, right? The main idea is just to like assign unused numbers to the first card in the pair, right? If we do that, then we are fine. And then yeah, you can have a set of cards for which only one instance is opened, but yeah, you got time limit exceeded on C because your algorithm was n cubed for n up to 10,000. Okay, I don't know how to comment that. N square log n. I don't know. I don't know what you were like. Yeah, I still wonder how to solve it in 5 minutes, but it's okay. Okay, what is D? I don't know what D is. Like, it looks like some like dynamic programming on broken profile problem, right? Just like something that like yeah. But the question is how to actually implement it, and my solution was kind of the most lazy way. I didn't want to store any information. Like I had just a map from the whole board state into the number of ways to achieve it. And then I just go cell by cell top left to bottom right. And for each empty cell, I try to put some chips into that cell from 0 to 3. I update the state of the board and just do the transition, right? So like that's kind of a brute force solution if I don't say anything additional. I just like that's kind of I can implement a recursive like brute force solution, like backtracking solution, right? In each cell I just try to put something and then like my board state changes and so on. I just recurse. Then I can add memorization to this solution, right? I can just save the current board state. If it's not different after some different sequences of steps, I can just like save the result and finish there. I guess that's like also works. I just implemented it iteratively, kind of. But then another idea which is important is that if like I cannot change anything for some cell, for example, and it's not 0 eventually, like some cell which had a number doesn't have the correct number of chips around it, I can just stop, right? Like if I know that the cell will never have the needed number of chips, like it has some number, if it's too big already, then of course I will not have the needed number just because it's already too big. I cannot make it smaller. I can only put additional chips. And if at some point like the opposite happens, for some cell I have some number of chips around it and some empty cells around it, and even if I put 3 chips into each empty cell, I still don't have enough chips around the cell, I can also stop. Like this is the 2 main optimizations. And you just type them, and yeah, I just prune it when constraint can be satisfied, and it passes in 3 milliseconds, because why not? So yeah, I don't really know, like it's I don't know, like I actually thought for quite some time about how to implement it. That was probably the easiest way, but like I hoped for something more systematic. Maybe not looking as much as this code like brute force. Like this code looks like brute force, kind of. Okay, yeah, this problem is kind of interesting. Like I couldn't figure out at first what it was, like what the solution was. Like you have a grid of cells and points as well, and you have some squares cut out of the grid, like kind of you have a piece of paper, let's say, and you have some squares cut out of this piece of paper, which like the squares are 2i, 2j, 2i plus 1, 2j plus 1 for each I and j. So it's like not a checkerboard, like each 4th cell is cut out. You can imagine how it looks like. I don't have anywhere to draw. And yeah, the question is how to get from one point to another point in the shortest possible way. You want to draw some kind of line, probably a polyline, starting at point A, going to point B, and not going through cut out cells, right? And the idea is that actually, first of all, yeah, you don't need to actually move outside of the X range you have and outside of the Y range you have. Like your path, let's say your initial point is to the bottom left, of the final point, of the finish point. Once again, I'm actually like using my hands to explain stuff, and you see it mirrored, but you get it. Like one point is to the bottom left to the other point, right? So the thing is, you only need to move like monotonically in both X and Y. You don't need to like do something weird like this, because it won't be the shortest path. So you only need to move monotonically. You only need to move through integer points, and in this way, in this case, like if the path is monotonic, you can just do dp, dynamic programming, high Murat, thank you for the raid. Hello, everyone. Yeah, once again, welcome to the stream. I'm actually going to stop soon. I finished my round, but yeah, welcome anyway. And yeah. So, yeah. And the idea of my DP solution in this problem is just that actually from point xy you can only go to some linear number of points without in a straight line without intersecting anything. But yeah, thanks again for the raid. Yeah. So just n cube dp, and also like I said, one point is to the bottom left of the other one. If it's not the case, I can just flip the grid one way or another to make it true. Yeah. So yeah, also some questions about old problems. You have solved E with A star search. Well, yeah, but like, okay, but the thing is like, you can build a graph of all points, right? And you can build all the edges. Yeah, n cube using Dijkstra. Yeah, that's reasonable. But like, you have n cube edges, and yeah, like you can just use any graph algorithm. A star, like, obviously should perform better in this case, but you can use Dijkstra and just get accepted as well, as you can see. But the question is, like, yeah, like, okay, you can do that. You can do that, but you don't have to, because you can see that the path is monotonic, so you can just, like, you can only build some directed edges and make the graph acyclic, and just use DP on these acyclic graphs. You use Dijkstra, but excluded all points which do not obey train inequality by at least 5. Well, that's kind of like, yeah, it's an interesting idea. Like, I can't say if it's right or not, like if it's always right. Yeah, I can't really say, but oh, timed out Galvanov for 5 seconds, really? Nightbot, come on. Sorry about that. I guess I'll have to figure out the settings. Can you please repeat? You used caps. Yeah, I see. It's okay. It's okay. Yeah, someone also asked about problem D, what the complexity of my solution would be for a grid of all zeros. And it would just be polynomial. Like, I only, like, the state of my grid is only the number of chips I need around each cell. And like, the problem is each cell is either empty initially and then you can put some chips into it, or it has some number and then you cannot put chips into it, but you need to satisfy the condition. And then if all cells are empty initially, then like I only maintain the number of chips I need in each cell. I forget about how many chips I put into each cell, because I don't care in the future about that. I only can save that information, like the number of remaining chips I need to have around each numbered cell. So if all the numbers are 0 initially, like after anything I do, all the numbers are still zeros. Dijkstra on ellipse. Dijkstra on ellipse. Yeah. Actually on ellipse, yeah. Okay. Okay. Yeah. Caps totally reasonable. And then, yeah, the last problem was problem F. Yeah, how to solve F, by the way? Like, I just did Dijkstra for a graph of n times 13 vertices. Like, my state was where I am and how much like what time of day it is. And I just minimized the time. But yeah, okay, you can do it with n vertices. Oh yeah, you can, okay. You can, okay, you can just do, yeah, you just minimize the time, right? But then the transition function is tricky, right? You cannot just use the, like, you cannot just build a graph for which the shortest path is the answer, right? Yeah. Yeah, you can just do the extra with some funny edge lengths, yeah. Mm-hmm. Right. Okay. Yeah, that's better. Also, since the edge weights are at most 12, you can do, I think you can do 0, 1 BFS on the graph of 13 n vertices. If you maintain not the distance in each vertex, but like the day number, it will be a 0, 1 BFS. So it will be n times 13 time overall. But yeah, that's more tricky to implement. Okay, anyway. So the series is over. The fifth round is over as well. Thanks to everyone who watched this series. Yeah, I might stream some more contests later. Be sure to follow me on Twitch to know when the next stream happens. And also, as usual, you can check Codeforce's streams panel here, where I will post stream notifications, which is probably the best way to announce my streams, just because for now most of my audience comes from Codeforces, which makes sense. Yeah. Thanks. For watching. What about such case in D? Yeah, sure, let's try. Okay, so the answer is some big number. Okay, the idea is that it's not O of answer, because like after I finish the first 3 rows, I only save my current state if it satisfies the 10th, yeah, like show the test case. Like after I process the first 3 rows, I only keep those states that satisfy this 10 and this 10. Like if this 10 is not satisfied after I process the 3rd row, it will never be satisfied, right? So that's the pruning trick here. So it's not of answer, at least, because like after the first part, I kind of stop and like all the states are the same. So it's at most square root of answer, and actually it's even smaller, yeah. Yeah. When for K on Codeforces? I don't know. Given that I have 3.8K, I'm kind of hard stuck at 3.8K, right? Okay, I had 3.9K last contest, but like the losses are really harsh. Like I lost 170 points, 170 points. And for winning, I get less than 100. So yeah, I need to win 3 contests in a row now to get to 4K from this point, which is not easy, you know. But I'll try. Yeah, totally unfair, I agree. Okay. I am 27. Yeah. Okay. Thanks again. I am ending here. Thanks for watching. Check the schedule on Codeforces. Check my Twitch. Follow my Twitch. Take care. See you all and goodbye.